So in this lesson, we're going to understand the divergence of the harmonic series, summation 1 over n. So let's recall some of these terms. So when we start doing calculus, we want to talk about infinite series. So an infinite series is a sum, n goes from 1 to infinity, of a bunch of real numbers. So in order to make sense of this, of course, the way to make sense of an infinite sum is you can't just add up a bunch of infinitely many numbers. You define the notion of partial sums. So we say S1 is A1, S2 is A1 plus A2, S3 is A1 plus A2 plus A3, etc. And so from this series, that is an infinite series which is a sum of infinitely many terms, you get a sequence of numbers, S1, S2, S3, etc. And we say that summation an converges if this sequence S1, S2, S3, etc. has a limit. If it doesn't have a limit, otherwise, if S1, S2, S3, etc. does not have a limit, then we say summation an diverges. Fine, that's the technical definition. What we want to see today is the claim, or the proposition, if you like, summation 1 over n diverges. Or more precisely, as you keep taking the sums of reciprocals of the natural numbers, then this infinite sum goes off to infinity. So let's see why this is true. Let's write down a proof, if we can, of this fact. So in order to prove this, I'm going to go over to the next page. We need a picture. And because I want to draw this picture, I'm going to turn the page over. Here's my picture. I'm going to draw the graph of the function this is y equals 1 over x. Okay. So let's say this right here is 1, 2, 3, 4, and so on. So I'm going to draw some rectangles here. Okay. The first rectangle I'll draw is this one. It has base going from 1 to 2, and its height is going to be the height of the function at 1. So it's this rectangle here. And what is the height of the function at 1? Well, it is the function 1 over x. So this height is 1 over 1, so this is 1. So in fact, this is a square, base 1 and height 1. The next rectangle I'll draw, I'll go from base 2 to 3, and height is whatever is the height at the left endpoint, which is 1/2. Why 1/2? Well, it's 1 over 2, because I'm going up to the graph of 1 over x. So here's my second rectangle. And then you can see the pattern. The third rectangle I'll draw will have base going from 3 to 4, so still base length 1, and this height is 1/3. And you can see that the rectangle, each rectangle that I draw is above the curve, but it's kind of getting closer and closer to the curve as we keep going off to the next step. But what is clear is, from the picture, each rectangle has area bigger than the area under the curve. What am I saying? If I take this rectangle here, this whole area is more than the area trapped under the curve and above the x-axis. The area of this rectangle is more than this area here. That's the area trapped under the curve and above the x-axis. And so if I just shade all the area under the curve, this total area is always less than the sum of the areas of these rectangles. So let's write down what this picture is telling us. Okay, so this picture is saying, i.e., 1, which is the area of this rectangle, plus 1/2, which is the area of this rectangle, plus 1/3, which is the area of this rectangle, dot, 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 is bigger than or equal to the area under the curve. Y equals 1 over x. Now we're not going to take it all the way out to infinity just yet. Let's just see what happens if I go from 1 up to some number. Okay, so 1 plus 1/2 plus 1/3 plus dot 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 plus 1 over n is bigger than or equal to the area under y equals 1 over x from 1 up to n. So what I wrote down here was where n is equal to 3. 1 plus 1/2 plus 1/3 is bigger than or equal to the area under the curve y equals 1 over x from 1 to 3. Okay, so if I stop at any stage n, this is true. So therefore, summation 1 over n, as n goes from 1 to capital N, is bigger than or equal to the area under the curve, which of course, as we know in calculus, is the integral from 1 to n of the function 1 over x dx. But we know antiderivative of 1 over x, or an antiderivative, and this is the natural log of x from 1 to n, and therefore summation n goes from 1 to n of 1 over n is bigger than or equal to the natural log of n. Well, really, natural log of n minus the lower limit, natural log of 1, but that's equal to 0. So this plainly shows you that as I keep increasing big N, this sum is going to get bigger and bigger. So, for example, if big N happens to be e to the power 100, then summation is bigger than or equal to the natural log of e to the 100, which is 100. And if I take e to the 1000, then this sum becomes bigger than or equal to 1000. So in particular, if this upper limit keeps going higher and higher and higher towards infinity, then this sum also goes higher and higher and higher towards infinity, i.e. summation 1 over n diverges to infinity. And there we have it, the geometric proof of this fact, just from using the graph of y equals 1 over x.